All right, let's take a look at a few problems on page 257. I'm going to be working backwards, essentially. I'll be given an area or a probability first, and then I need to find a z-score or an x-value if we're looking at a non-standard normal case. So let's take a look at this first one here. Now, the instructions are to assume we're working with the standard normal table. So what they're asking for in this problem is they're asking for the 80th percentile. So let's take a look at a sketch of what that means. Okay, so we're going to assume standard normal. Okay, and we want to find P sub 80. Okay, so what this translates to is the 80th percentile. Now, percentiles are cumulative areas which read from negative infinity up to the value in question. So the 80th percentile, say for example, if we're talking about IQ scores, the 80th percentile would be the IQ score that separates your score from, or pardon me, the 80th percentile for IQ scores separates the upper 20% of IQ scores from the lower 80% of the IQ scores. For example, the 50th percentile would be the mean because half the values on a normal distribution, 50% are below the mean and 50% are above the mean. So again, the mean would be the 50th percentile. So I'm going to go ahead, and since we're working with standard normal in this case, I'm going to sketch a standard normal. Now I'm working without a net here because I'm writing in pen, so hopefully I won't make too many mistakes. And I'm going to put 0 in the middle. And what the 80th percentile means is I want this z-score, okay, to separate this running total, as you will, of 80% of the z-scores, okay, I want 0.8 here, from this upper tail of 20%. So in this problem, we're given this value first. We're given the area first, and then we want to get the corresponding z-score. So on our standard normal table, I know I need to go to the page where the z-values are positive because I know that any z-score that has a corresponding area above 50% is going to be positive. Okay, so in this situation, I'm going to be reading in the body of the table and then outward as close as I can get to that z-score. Okay, so 0.8 for a cumulative area. Okay, as close as I can get in the body of my table is going to be a z-score of about 0.84. If I'm looking at this correctly. Okay, so 0.84. Okay, so z in this case will be 0.84. Now let's take a look at how to get this on the calculator. Okay. Now, one thing to keep in mind for the calculator is that our input is a cumulative area or a cumulative probability. So it can never be negative and it can never be greater than 1 or 100%. And it's an inverse function. Okay, previously when we were working with the normal cumulative distribution function, we were given the z-score or the x-value first, and then the output was a corresponding area or probability. When we're working with an inverse function, or in this case the inverse normal, our input is going to be the area or the probability, and our output will be a z-score or an x-value. Okay, so on the calculator, again, I want to go to my distribution menu, and my third choice here is inverse norm, and that stands for the inverse normal function. It's expecting a cumulative area from negative infinity up to the z-score in question. So my cumulative area given in this problem is 0.8. So I want to put in 0.8. And then I want to leave mu and sigma alone. It defaults to standard normal because I'm working with the standard normal distribution in this case. Okay, so if you're working with an older calculator, once you select inverse norm, it's going to get you back to your home screen, and this is what it's going to need. It's going to need a cumulative area separated by parentheses, mu, and then sigma. Now, if you close the parentheses right here, you're going to tell the calculator we're working with standard normal. Now, in our next example, when we are looking at the non-standard normal case, then you would just extend these two values here. Okay, so a cumulative area of 0.8, okay, for this problem, and then I would close parentheses if I was working with the older calculator. Okay, so I have those pieces put in, and I just scroll down to paste and then put enter. Okay, so the calculator carries the z-score a little bit further. Again, this supports the situation of our table being a bit limited. Okay, it only carries out z-scores to 2 decimal places. So you can use technology and carry it out further. So this corresponding z-score, if I rounded to the nearest hundredth, would be consistent with what I got when I used the standard normal table. Okay? So let's do one more quick example on the standard normal case, and then we'll look at the non-standard normal case. Okay, number 20. Let's take a look at this one. Okay, we're told that it's standard normal, and I can tell because 0 is in the middle, and they're using the notation z. Okay, and z is reserved for standard normal. Okay, so we want to know the z-score that separates an area in this upper tail of 0.0233. Now, the calculator and also the standard normal table reads from negative infinity up to this point. Okay, so our input is not going to be 0.0233. Okay, so what I'm saying here is I have this upper tail shaded, and it has an area of 233. We want this z-score. Okay, but our standard normal table needs this cumulative area, and also our calculator needs that cumulative area. So to get this part, I can use the fact that it's going to be 1 minus this upper tail here, because the total area under the curve is 100%, or 1. Okay, so the area that I need to input into the calculator is 0.9767. Okay, now that would be the area you would try to find in the body of the table, or get as close to as you can in the body of the table, and then read outward. So again, I want to go to my inverse normal. That's option 3. And my cumulative area is 0.9767. Again, I'm on standard normal. Okay, so that z-score is approximately 1.99. Okay. Now, if you're super lazy and you don't want to do the subtraction separately, you can go to your distribution menu, and in your area, put 1 minus 0.0233. It should be able to handle that calculation inside there. Okay, and there we go. Okay, now let's take a look at an application problem for the inverse normal function. Okay, heights of men. In a survey of men in the United States aged 20 through 29, the mean height was 69.4 inches with a standard deviation of 2.9. Okay, and we're told in the instructions that this is a normal distribution. Okay, so answer the questions about the specified normal distribution. So part A, what height represents the 90th percentile? And part B, what height represents the first quartile? Okay, so let's go ahead and put down what's given in that problem. Okay, first we're given a normal distribution. Okay, that's the heights of men, with mu is equal to 64.2 and sigma is equal to 2.9. Okay, so we know right off the bat this is not standard normal. Okay, so if we were to do this by hand, we're going to have to first get a z-score and then unstandardize to get a corresponding height. Okay, so the first part is what height represents the 95th percentile. So what they're asking for is p sub 95. Okay, so I want to go ahead and sketch a standard normal distribution, and I first want to get this z-score. Now I know my z-score is going to be above 0 because the cumulative area I'm given is 0.95. Okay, so sketching this, putting 0.95 here, I want the z-score that separates the lower 95% of the z-scores from this upper tail. Okay, so looking in the body of the table, I know my z-score is positive, so I'm looking at that second page. So 0.95. Okay, so it looks like it's about halfway between 1.64 and 1.65. Okay, so it looks like it's exactly halfway between these two z-scores. So I'm going to call this z-score 1.645. Okay. Now this is not going to be the final answer. This is not a height. This is a z-score. So we're going to have to unstandardize that. Okay, so remember the relationship here between x and z. Z is equal to x minus mu over sigma. So resolving this for x, then x will be equal to mu plus sigma z. Okay, so that's just some simple algebra to go from here to here. This formula is given on your formula sheet, so you don't really need to memorize it, but hopefully, given the fact that this prerequisite is intermediate algebra, you understand how this formula is derived from this formula. Okay, so to unstandardize, to get that x value, I'm going to put in mu of 64.2 and then plus sigma, which was given to be 2.9, okay, from the problem, and then times this z-score of 1.645. Okay, so doing that calculation, 64.2 plus 2.9 times 1.645. Okay, so it's about a height of 68.97 inches. Okay, now hopefully that makes sense. Okay, we're looking for a height that's the 95th percentile. The mean is given to be 64.2, so we certainly expect a height that corresponds to the 95th percentile to be larger than that. Okay, so this answer makes sense with respect to the problem. Now there is a quicker way to do this in the calculator. Okay, if you have the older calculator, you want to go back to that inverse norm. Okay, and you want to put in that cumulative area as a decimal. Now instead of closing the parentheses, we can have the calculator unstandardize for us and return an x value. So to do that, in order, we need to put mu and then sigma and then close parentheses. On the newer calculator, we're going to go to the distribution menu, which is the same place as the all the TIs. Okay, we're going to go to inverse norm and put in the area of 0.95. Now here is where we can change mu and sigma. Okay, so mu is 64.2, sigma is 2.9. Okay, so the answer that the calculator returns is very close to what we got when we approximated that z-score using the standard normal table, and then we went ahead and unstandardized it. Okay, so again, x is approximately 68.97 inches. You can round to however many decimal places you need to round for your problem. Okay, so I hope that helps you understand how to use the inverse normal function, okay, to answer questions.